Today we will talk about additive manufacturing materials. In additive manufacturing, we have several kind of 3D printing technologies that we can use and several kind of materials that can go with that specific 3D printing technology that we want to go through in order to develop our final 3D product that we designed already. So we will start with the FDM materials. So it's very important that you choose the right type of material to print the object that you want. And with having a lot of technologies for 3D printing and a lot of material choices, this decision is becoming very difficult, especially when you are caring about all types of properties for the produced parts and all types of application that this part will play a role in. So 3D printing market seeing an emergency of radically new materials. So every day there's new technologies merging in the market and the new materials being introduced for the users, engineers and hobbyists. So for FDM 3D printing, the main two materials that usually you hear about them a lot is the PLA and the ABS. Basically, these are the two main polymers that are introduced in the market and used. It's usually can be considered that this dominance is happened just by chance and the market didn't find better solutions or better materials to compensate these two. So that doesn't mean these two materials will keep dominating for the FDM printing. Maybe new materials will be introduced with a lot of positive properties to dominate over the PLA and the ABS. So the materials usually are graded through three main categories. Firstly, when you want to decide a certain materials to be used for your 3D printed part, you focus on either mechanical performance or visual quality or the process itself. So mechanical performance in terms of durability, in terms of impact resistance, thermal resistance, and so on, as we will discuss moving forward. Visual quality, how good does your part look? Do you care a lot about having a transparent part? Do you want the part surface finish to be as smooth as possible, and so on? For the process side, then you need to know how long does it take the 3D printing technology that you chose, how long does it take to produce your part using that specific material. So moving forward, we will break down these categories and discuss more about them so that we will have a better picture or a better understanding for each polymer properties and applications, so that we will easily decide which material to use based on the application that we are going for. So again, to choose your material, it depends so much on what you want to print. So as you can see in the graph in here, we're focusing on the key decision criteria that's needed to choose a material. Firstly, you will focus on the ease of printing. How easy is it to print this material? Is there any kind of technical complications? Is there any kind of post-processing complications? And so on. Then the visual quality. How good does your part look if you print it through using this material? Max stress. How much stress does this material handle if I printed my part using it? Then the elongation at break, which means how much can I stretch my part before it will be teared down or teared off. Impact resistance, if your application where your part will be deployed, does your application involve some kind of impact forces or repetitive loading, then you want to focus on the impact resistance in that case. Layer adhesion, how good is each printed layer sticking to the next layer? Are they well merged to each other? Are they well fixed to each other, or they're easy to be peeled off? As well, we are focusing on the heat resistance. If you have your part to be deployed in a thermal application, then for sure you will focus about the heat resistant behavior for the material that you chose. So let's start with the ease of printing. As we said, how easy can you print this material? This involves the bed adhesion, maximum printing speed, the repetition of the filled prints or the frequency of the filled prints, then how accurate is the flow, how easy is it to feed the material into the printer. And I can add as well, how easy is it to get this material from the market? Is it available? Do you need to do extra effort in order to get one of these material cartridges or not? For visual quality, how good does your finished object look like? We can see here a block that's 3D printed. We can see using some materials, you can see the post-processing. Some materials you can see the layers. Some materials they have some kind of reflection. Some of them, if you test them in the lab, they will have different mechanical properties. All of these will play a role in deciding the visual quality for the part. In terms of maximum stress, then what is the maximum stress that the object can handle before it will collapse or break? So if you take the part and you do kind of pulling forces on it, axial loading forces on it, then how much stress can it handle before it fail? For the elongation at break, what is the maximum length that the object can handle before he will break in terms of stretching? For the impact resistance, how much energy is needed in order to break this object by applying a sudden load or a sudden impact on it? For the layer adhesion or isotropy, we are focusing here how good is the adhesion between each layer of the printed material. We are saying isotropy because isotropy, as we discussed before, is the uniformity of the part in all directions. So the more the layer adhesion is, then the more the isotropic the object will be. For the heat resistance, what is the maximum temperature the object can handle before it will melt down or deform? We can see here an overview for these properties that we focus on while trying to decide on which material to use for our print. Then we have here each material is colored differently, so we can see here for the ease of printing, the score for the TPU material is low, for the ABS and the PC is a little bit more than low. For the nylon, it's medium. How easy is it to print the nylon is medium. Then for the PET, it's above medium. For the PLA, it's very easy to print using PLA. For visual quality, we can see here the PLA still giving you above medium visual quality compared to the PET, ABS, nylon, TPU, and PC. Maximum stress, in this case, the PC will give you maximum stress if your printed part will go through a lot of stresses in the application you're designing for, then the PC is the way to go. Or the PLA is still above medium and beating the other materials like ABS, PET, nylon, etc. So still, PLA is still a good choice. For elongation at break, most materials mentioned below are scoring low resistance for elongation at break. Nylon is considered medium, but the TPU giving the best score in terms of elongation at break. For impact resistance, TPU is scoring the highest as well. So it means elongation impact are mechanical properties. So you can see the TPU have a good mechanical properties. Below that, the nylon, then will be followed by the PC, ABS, and PET, but the PLA fails to handle a lot of impact resistance. For the layer adhesion, then the PLA still gives a good score. So in terms of heat resistance, PLA and nylon will give a bad scores. For the TPU and the PET, still a little bit above low. The best results for heat resistance, you should go either with PC or ABS for heat resistance. So just a summary for this kind of data representation in terms of 3D printing features, we can see here in most cases PLA is giving good scores, except if you're having heat resistance or impact resistance involved in your application, then you want to look into other choices, which could be the ABS in most cases. So PLA, as we said, it's a polymer called polylactic acid. It's the easiest polymer to print and give you good visual quality. Not the best, still looks kind of plastic visual quality, but still good visual quality. And it is considered rigid and strong, but still brittle. So this is why it can't handle a lot of impact resistance, because since it's brittle, it will break apart. So we can see here kind of 3D printing properties for the PLA. You can see it gives good score in terms of ease of printing, very easy to print, very easy to reload the material into the printer. Visual quality is medium, maximum stress is medium, layer adhesion considered medium or above medium, let's say, but it will fail if your application having a lot of elongation or impact resistance or heat resistance. So we can say, generally speaking, mechanical properties are mostly bad for PLA, except for the stress. It could handle a medium amount of stress. So the pros and the good sides for the PLA, it is a biosource, biodegradable material. It can dissolve after a while through the natural dissolving sources. It is odorless, doesn't have any kind of bad or harming smell. It can be post-processed with, for example, sanding paper, and it can be painted with acrylics as well. It have a good ultraviolet resistance. So these to keep in mind as a good sides for using the PLA in the FDM 3D printing. The bad sides of it is having low humidity resistance. So maybe if you keep the material for a long time in a humid place, then maybe your part will be it will be distorted. Then it's hard to be glued. If you want to glue the PLA part to another part, if you're doing a printing of parts to be assembled eventually, then it could be hard to glue the PLA, or maybe the glue, depending on the glue type, but the glue may eat this material or distort it or give it bad side effects. So that's something to keep in mind. For the ABS, it is a lot of times, if you're not going with PLA for FDM, then you go with the ABS material, especially if your application involves high temperature resistance or high toughness, and as well could be in some cases impact resistance as well. We can see the properties map for ABS. It's doing a good score, considered very good in heat resistance, considered a little bit less than medium in impact resistance. Then maximum stress is a little bit under medium, visual quality a little bit under medium, layer adhesion is considered low, elongation at break is low as well. The good sides for using the ABS, it can be post-processed using acetone vapors if you want a glossy finish. It can be post-processed as well using sanding paper, and can be painted with acrylics as we mentioned. Acetone can be used as a strong glue or a layer that strengthens the part. it have a good abrasion resistance. The bad sides of it, it is sensitive to ultraviolet lights. It have kind of smell that could be unpleasant for some people, or could, I don't have any kind of research background about it, but it could have bad effects on health and so on. So that's something to keep in mind. It's potentially highly fuming emissions, so it will give you you will have all kinds of smelly you will have all kinds of different smells or odors during printing and during post-processing or for the part itself. If you want to go with the PET material, polyethylene, it is slightly softer polymer, and it is considered as a rounded polymer during printing. It has different kinds of additional properties and have a little drawbacks and little downsides in terms of properties. So if we look at the properties map for the PET, ease of printing is considered above medium, heat resistance is bad, or let's say low, layer adhesion considered medium or less than medium, impact resistance medium, elongation at break is low, maximum strength is medium, visual quality is considered somehow medium. That's so this graph, keep in mind if you want to go with this material, it's worth going back here and taking a look to know if this material is meeting your application. Good sides for this material, it can contact with foods with no any kind of harming or side effects. It have a high humidity resistance, it have a high chemical resistance, it can be recycled, it have a good abrasion resistance, it can be post-processed with sanding papers and can be painted with acrylics as well. Bad sides, it's considered heavier than PLA and ABS. If your application if the weight of the part is a concern for you, then it's worthwhile designing. A lot of 3D design softwares give you the option to know the weight of the assembly or of the part. So it's worth assigning the PET material for the part and knowing what is the weight for the part compared to if it was printed with the PLA or ABS, just to keep in mind that part. If you go with nylon, nylon have a good mechanical properties, and it have in specific a very good impact resistance, even though it is a non-flexible filament, but still having good impact resistance. However, the layer adhesion for this material is considered very low. The properties map for the nylon material showing you impact resistance is very good, heat resistance is very low, layer adhesion is very low, ease of printing considered a little bit above medium, visual quality a little bit above medium, not great, maximum stress, it can handle less than medium stress, elongation at the break is considered medium. The good sides of this material, it have a good chemical resistance. If your application involving chemical materials, then that's a way to go. It have high strength. The bad sides of it, it's not resistant for moisture. It can give you some kind of odor or high fume emissions. For the thermoplastic polyurethane, known as TPU, it's used in most cases for flexible applications because it have high impact resistance and can be a good choice for many applications that are involving some kind of impact loading. Good sides, it have a good abrasion resistance, it have a good resistance to oil and grease. Bad sides, it is difficult to be post-processed, it can't be glued easily. Either the material will be distorted or the glue doesn't stick to this kind of material for chemical reasons. For the polycarbonate, known as PC, it is considered the strongest material of all for the FDM 3D printing technology. It can be a good alternative for ABS, where the properties are almost similar. If we look at the map for the polycarbonate, so we can see the heat resistance is perfect, it's very high. Layer adhesion is considered medium, impact resistance medium, elongation at break is low, maximum strength is very good, visual quality is a little bit under medium, ease of printing is considered low. It's not easy to print using this material. Good sides, the bad sides I mean for this material, it is sensitive to ultraviolet light. Now if we compare the PLA versus the ABS, so ABS is considered common thermoplastic in the injection molding industry. It can be used for application like the Lego that you see in the market, or if you want to do electronic housing, and which we mentioned about as enclosure before, and even in automotive bumper parts, that can be a solution as well. For the PLA, it can degrade through time as a biodegradable material. It is derived from renewable resources like the cornstarch or the sugar cane. It's considered one of the most popular bioplastics. It can be used for a lot of applications, starting from plastic cups up to the medical implants applications. So if we compare side by side the properties for ABS and PLA, for tensile strength, you can score with ABS for a certain sample 27 megapascal. For PLA it will be 37 megapascal, so higher tensile strength for PLA. Elongation, it can go 3.5 up to 50%. For ABS, for PLA only 6%, so ABS wins for elongation. For flexural modulus, then you can get 2.1 up to 7.6 gigapascal for ABS, but only 4 for PLA. So ABS wins here. For density of material that is printed, you can go from 1 up to 1.4 gram per centimeter cube. And for PLA, 1.3 gram per centimeter cube, almost similar. Melting point is ABS is amorphous material. There's no number issued as of now. For the PLA, it can handle up to 173 degrees Celsius. Again, ABS having a good thermal resistance, so that means ABS wins in here, even though we don't know the exact number for melting point. For biodegradable, ABS is not biodegradable if you care about an eco-friendly application. PLA can, but you need to care about the correct conditions of the application. For the glass transition temperature is 105 degrees Celsius for ABS. For PLA it's only 60 degrees Celsius, so ABS wins. For the price, you can see that almost identical for 1 kilogram for 1.75 millimeters. And for common products done by ABS, Lego and electronic housings and enclosures, for PLA, cups, plastic bags, and so on. General rules for PLA and ABS. So ABS and PLA are very common for desktop FDM printed material. They are almost similar in cost as we mentioned. ABS have a very good mechanical properties, but it's harder to print compared to the ease of printing for PLA. PLA is very good for 3D prints where you care about how good does the part look like. It have a lower printing temperature, so it's easier to print with, and it's better suited for parts with fine details. ABS is fitting very well for applications where you care about strength, ductility, and machinability, and even thermal stability. ABS is more resistant to warping than the PLA.